Well, now I'm going to show you how to turn any microphone into a wireless microphone using ultra high frequencies or very high frequency, or better known as UHF and VHF, in an inexpensive way. It's not the same thing to say inexpensive as saying cheap. So we have these transmitters. You have seen them on some other videos. I use it for wireless connection of my guitar, and I was thinking that what if I put those transmitter or a receiver into a normal microphone like this one? And how am I going to do that? Well, I have this Shure PG48. This is a normal XLR microphone. XLR are for sending balanced audio to the main mixer. But let me show you something else. I have this other microphone. This is a wireless microphone, but I don't have the bass anymore, and you cannot just use any bass. It is a very good quality microphone. It says professional, but I don't think it is for professional microphone. It doesn't even have a brand. It just says D. But look at the cardio, the transducer element. It's very good quality. It used to have this plug here to connect the transducer element. I pull out all the electronics, so now we just have the transducer and the base or the case. But look at the mic. It has a very good sound quality, but again, since I don't have the bass, I cannot use this with other basses because they have proprietary circuits and frequencies and things like that. But this is the circuit that was inside the microphone. Very simple one. Maybe it's just an FM transmitter. I don't know. But again, I'm not using it for its transmitter quality since I don't have the receiver. I'm using it because of the audio quality of it. So these are the transmitters I use for my guitar and bass guitar. They have a very good future, like 50 meters of range and long-lasting battery. They doesn't introduce any noise into the audio. You just click here and you can find another channel in case you are using 4 of these, because they don't get interference because they have like a codification for the transmission. But okay, I forgot to put the button in this one. So, okay, so I just click the channel search and now they are in sync, and I'm not meaning the voice band. They are in synchronization. If I click here again, they lost communication, so I have to click in the other one again so they can change to another channel and find the receiver. Oh, I don't find it. Okay, here is. Look at it, and now again they are in synchrony to transmit and receive. So if those are good for a guitar, why not using it in a microphone to transmit voice? I have created this adapter. It has XLR female in one end, so you just plug it right there in the microphone, in an XLR microphone, and you just insert the transmitter into the female 1/4 inch jack. These are like for the big headphones, but this is monaural, it's not the stereo. So I plug the receiver in the mixer, in the transmitter into the microphone, turn it on, and look at this meter. I turn on the microphone, pop up the volume, and we have sound. As you can see, the mixer is registering sound. So that's what easy. You see, it is wireless transmission of audio in the microphone. I can change a channel here, and it got disconnected. But if I click on here on the receiver, it's going to find the channel again, and we have sound again. This was very easy. So thank you for watching this video, and see you next time. No, so kidding. Let's see how to create the adapter. XLR connectors are for balanced microphones. This means that the microphone sends two signals to the mixer, one normal signal and the other inverted. So if the mixer has balanced inputs, it will combine those two signals and they will get eliminated one with the other because they are opposite one to the other. So the remaining sound is noise, so it gets eliminated by the console. So the console or mixer, it retakes the original non-inverter signal and mixes it with the rest. They do this to eliminate noise that get into very large cables. But with wireless microphone, you don't need this since you are not using wires. There could be some transmission noise by the FM frequencies, but each company implements in their transmitter and receiver their own noise reduction, and some companies doesn't do that also. You get very cheap products. Sometimes people complain how expensive are some microphone or products are compared to other products that do the same exactly, but again, some professional wireless microphone implements highly complex circuits to avoid noise, to make the signal private, to reduce delays, and many other options to make sure that they are not going to let you down in the middle of a concert or a playing. So going back to our adapter, in order to create the adapter, we will switch to a female 1/4 jack and connect the number 2 pin from the XLR to the tip of the 1/4 jack. And number 1 and 3 from the XLR connection are going to be connected to the ground or the slip of the 1/4 connector. It could be female connector, it could be male connector, doesn't matter. But in this case it's female because our adapter is male. I already have this Shure PG48, it costs about $30. It has a very good quality sound. It's not a professional like the SM57 or 58 or Beta series, but it is good. A Shure wireless microphone can cost you just the microphone like $170, $190 without the bass. These are if you already have the bass, you can just add another microphone to it. A Shure microphone with the bass also, it costs around $300 and $700 depending on the model, and they cost that much because of the complexity of the security and all the stuff they implement again. If you're not a professional, you could just buy this very cheap lavalier mic, but look at how badly it is qualified by other users. Very noisy, very low performance, battery doesn't last, and so on. Also, there are some other mics with very cheap but good sound quality. The problem is that they use Bluetooth, so they need a Bluetooth adapter or receiver and also have a delay because of the Bluetooth protocol. There are other very inexpensive wireless mic with good quality audio from $20 to $100, but you have to take into account that one thing is the radio transmission quality and the electronics quality and efficiency, and another very important is the sound quality or the cardio element used as a transducer for the acoustic audio quality. And finally, we have our set of transmitter and receiver for guitar or bass guitar or other instruments that have a very good quality on transmission, so we just add a highly quality microphone and we have a complete series of wireless mic set. Some companies already have this idea and they pull out a series of XLR wireless adapter, but they are costly and the cheap ones have very short battery lasting and some noise. You can also buy this very cheap wireless microphone. It has a regular sound, but the battery doesn't last too much and it has its issues. So yes, there are cheaper options out there, but not with very good quality or dependability. Good quality enough for using your karaoke or practice. Our models, the ones we have here, cost like $15. And sometimes you will see it for $20, and if you already have a good microphone, you have a more expensive and quality option with a little of investment. Let me show you the internals of the transmitter for our models. I'm going to disassemble so you can see and compare it with other options in the market. Of course, just watching the circuitry won't tell you anything, but just to have an idea of how complex these transmitter and receivers are. I was planning on replacing the battery for a bigger one, but this gives you 4 hours. I don't think you need more than that. Here is turn it on. You see how complex this circuit is? It's not just the regular FM transmitters and that's it. I think it has coders and decoders and things like that. Let's put it in comparison with another professional series microphones or transmitters. Look how simple they are. Of course they look bigger because they are not using surface mount component, not much. But this looks highly complex compared to the cheaper ones. Well, this is cheap also, or again, it's not the same to say cheaper to say inexpensive. But the problem is that it's not fitting inside the case, and I don't want to cut it because we can damage the board. Well, we're definitely going to damage the board, so let me check other options. At the end, I just decided that I will install a 1/4 female jack in this mic since it has very good sound quality, and use the adapter like we were doing it with the Shure one. I know this is ridiculous to destroy a wireless microphone to convert it into a wireless microphone, but remember, I don't have the base for this mic and it has very good sound quality, so just pretend we are doing this with a very expensive XLR mic. The plan is to have the bottom of the mic to support the jack for the transmitter, so I need to close this part that leave a hole, and I will solder it with plastic. I'm not using epoxy glues or something like that to close this hole because at the end, I don't know if I don't mix it very well, but whenever it hardens or it doesn't stick very well, and I found that for plastic it's just better to melt the plastic, some kind of plastic or the same kind of plastic that you remove from other part, and it forms a very good and a strong bond, and it gets solidified as soon as it cools, like in 5 seconds. The trick is that you need to melt both parts, the plastic that you are adding and also the part that it should adhere. I melt both parts and mix them with like the tip of the iron. So like if you are gluing or something and mixing the two plastics, so they create a very strong, good bond. James Bond. Okay. Have you seen the movie? Well, now I will attach an audio shielded wire to the mic transducer, so I don't really need a shielded cable, but since the case is not made of metal, it is plastic, it can help us to reduce noise. And now that we have everything soldered, we can just put it inside the case and test the connections. Now we just insert the jack in the microphone, and the other receiver we will insert in channel 8 of the mixer, and of course turning it on, and remove the mute. And here we insert the transmitter into the microphone we just modified.
Testing, testing. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5. A, B, C, D, E, F, G. Yeah.
A, B, C, D, E, F, T.
It has a very good sound. Maybe you won't notice in your speakers, but it does sound without noise and with very much clarity. Let's put it against this Shure PG48.
Testing, testing. 1, 2, 3. 1, 2, 3. Testing, testing. 1, 2, 3. Testing, testing.
I really don't hear any difference with the other microphone. The quality is very good. I should have like a decibel counter on some other device to show you the measurement and not just my opinion. But since I don't have any of those, you will just have to trust me. Thank you very much for being so patient since I don't upload videos very often. Again, I have another job that demands so much from me. I hope this experiment is useful for you. Leave a comment in the comment section if you find it useful, if you have a better option or any comment. Thank you and see you very soon.